We are industrial engineering students at NC State University, and we are currently in an Introduction to Simulation class with Dr. Stephen Roberts. My name is Taylor Badgett.
My name is Rachel Longenecker.
And our third group member is Dashika Bale.
We are participants in the Simio project, where we need to compare two supply chain scenarios, one without a regional distribution center and one with a regional distribution center. Here is our scenario for part 1. As I said, this is our part 1 of the project, so there is no regional distribution center. This is the Caribbean model. In the Caribbean, we only have one country which has demand. This is Jamaica. Right here, our demand is represented with an entity state variable that is updated every time an entity enters. The entities enter every day, just like demand would. This path then happens instantaneously, and at the end of the path, we update our inventory levels by removing whatever the given entity state variable of demand was. Here, we have our reorder source. This is triggered on an event. This event is dependent upon our continuous review monitor. So when the reorder point goes, or when the stock on hand goes below the reorder point. This time path represents the travel time from Asia to the Caribbean. At the end of this path, the inventory levels are updated. It is very similar in our Central America model. In Central America, however, we now have 3 countries to account for: Costa Rica, Guatemala, and El Salvador. Here again, we have our add-on process trigger, which initializes all the inventories, the time paths, which represent the unloading and travel time, and the additional process, which updates our inventories. Here are the demands represented in each of these sources, and the inventories are again updated at the end of each of these paths. As you can see, we have a number of processes. We needed to make them for every country. On the on-run initialized, however, we have these assigned processes which will decide the initial inventory levels. We also have a number of definitions. In our elements, we have the monitors that I mentioned earlier, since this is the continuous review version. We also have properties, which include our initial inventory, our order up to, and our reorder point for every country in Central America. Then we have our state variables. There's quite an abundance of state variables, which represent the stock on hand, the stock on order, the holding cost, the good cases received, since there are some that come in bad, total sold, total ordering costs, and so on. We also have 3 events. In our South America model, which is very similar to the previous 2, we now have 2 countries to account for, Uruguay and Paraguay. Here I will show you the data table, which is present in the previous 2 models as well. This data table represents our demand, our travel time, the unload time, the operating costs, and transportation costs by country. These are all referenced in the processes that are hooked up to our main facility. We also have another table which gives the overall ordering cost, weekly inventory holding cost per case, sales price per case, manufacturing cost per case, and damage percent that I mentioned earlier. These again are all referenced in our processes.
Now we are going to show you the periodic review of part 1 with no regional distribution center.
This is essentially the same exact setup as the continuous review. However, the difference is the trigger on this source right here. Instead of having it based on a monitor, we now have it on an event. And this event is dependent upon a new property which we defined as the review period. As you can see in our main facility, we defined our review period as 7 days, so it is reviewed on a weekly basis. But as I mentioned, it is the same exact setup besides this source's trigger. So we will run this for you. For sake of time, I'm going to fast forward. As you can see, we have kept track of our global state variables, which give us answers for the project down here. This is how every model should be run for both Caribbean, South America, and Central America. We have found that the Caribbean runs the most smoothly when demonstrating. That is why we chose to show you the Caribbean. After we analyzed Part 1 with no regional distribution center, we found that the periodic review was not as optimal as the continuous. Here is our Part 2 of the project now, with the regional distribution center. Up here we have a source for every country that exists. On these sources we are representing the demand, similar to how we did in the first part. On the source, an entity will enter once per day. Before it exits, we assign it an entity state variable based on that country's demand distribution. Here, they travel almost instantaneously, just as demand would. At the end of the path, the inventory levels are updated. The difference with the regional distribution center is now that the inventory levels here are updated for the RDC, Regional Distribution Center. Then the RDC will deliver products to each country, which is represented here at all of these. These again are time paths, which represent the travel time from the RDC, which in this Simio model is Panama, to the corresponding country. Here it is Costa Rica. At the end of the path, we also have another process which updates our inventory levels. Now with the RDC, what happens is at the end of these paths, we update inventory levels at the RDC, and once that goes below the reorder point, it triggers an order from Asia. And Asia now only delivers to one location, which is the RDC. This is a time path which represents the travel time, and there is also a process that updates the inventory levels at the RDC once the entity arrives here. Since we knew continuous was the most optimal in Part 1, we only chose to do continuous for Part 2. I'm going to run this model for you to show you how it works. As you can see, we have labels again that are updating all of the variables for each country. At the end of this, I fast forwarded the run now, and we can evaluate results. We also performed OpQuest to get the optimal combination of inventory, initial inventory, reorder point, and order up to quantities. The last model of our project we are going to show you is the Miami model. So instead of traveling from Asia to Panama, and then Panama to each country, the regional distribution center is now located